Good morning everyone. Welcome to all of you in the home mentoring session from the SD Vidya School. This is a mathematics class. Now today we are going to recapitulate the chapter 8, that is Introduction to Trigonometry. In the recapitulation we will touch the different formulas that we used in this chapter, the different concepts and the different ways how we solve the questions. So let me start with the chapter. Now first of all, we will work on the history of this chapter. So let me start with the history. The origin of trigonometry can be traced to the civilization of ancient Egypt, Mesopotamia and the Indus Valley more than 4000 years ago. Some experts believe that trigonometry was originally invented to calculate sundials. The first recorded use of trigonometry came from the Hellenistic mathematician Ska in 150 BC. As all of you know that whenever we are saying about whenever we are working on a trigonometry, it means that we are working on a right triangle. So here we have a right triangle ABC. A triangle in which one angle is equal to 90 degree is called a right angle triangle. In the figure ABCD is a 90 degree angle. The side opposite to the right angle is known as hypotenuse. So AC is the longest side also. This is known as a hypotenuse. The other two sides are known as legs or base and altitude. AB and AC are base and altitude respectively. Sometimes for the altitude we use the perpendicular word also. So AB is the perpendicular and the BC is the base of this triangle. As all of you know that whenever we are working on a trigonometry, many times we use the Pythagoras formula. So here I am just explaining you the Pythagoras theorem. In any right triangle, the area of square whose side is the hypotenuse is equal to the sum of the areas of square whose sides are the two legs. As in this figure, AC square, that will be equal to AB square plus BC square. Now this is the trigonometric ratios. Now in the trigonometric ratio we have 6 trigonometric ratios. One is sine. The formula of sine theta, that is opposite side upon hypotenuse, and in general language we call it as a perpendicular upon hypotenuse. Next is cosine theta, that is adjacent side upon hypotenuse, and we know called as a base upon hypotenuse. Next is tangent theta, that is opposite side upon adjacent side. Yes, the formula will be perpendicular upon base. Next are the 3 trigonometric terms. These are cosecant, secant and cotangent. These 3 trigonometric terms are the reciprocal of sine, cosine and tangent. Let's start with the cosecant. The cosecant is the reciprocal of sine theta. So the formula will become hypotenuse upon opposite side and hypotenuse upon perpendicular. Next is secant theta, that is a reciprocal of cosine theta. So the formula is hypotenuse upon adjacent side and hypotenuse upon base. Cotangent theta, that is reciprocal of tangent theta. The formula is adjacent side upon opposite side. Now here the values of trigonometric function for angle C. In this PPT I am just explaining you the ABC is a right triangle and C is the angle that we are taking as a theta. So we are finding out according to angle C. Sine theta, that is equal to AB upon AC. AB is a perpendicular and the AC is a hypotenuse. Next cos theta, that will be a BC upon AC. Tan theta, AB upon BC. Cosecant theta, that will be AC upon AB. And then secant theta, AC upon BC, and the cot theta, that will be AC upon AB. We can see here that the cosecant, secant and cot are the reciprocal of sine, cos and cot tan theta. Now the next, this is a trigonometric table. In the trigonometric table, here we are thinking about that what are these things. These are the angles basically 30, 45, 90, 60, 0 degree. These are the different angles on which we will find out the value of sine, cos, tan, cosecant, secant, cot. So let me start with the 0 degree. At the 0 degree, in place of theta, if we will put down the sine 0 degree, the value is 0. Sin 30, that the value is 1 by 2. Sin 45, 1 by root 2. Sin 60, root 3 by 2. And the sin 90 is 1. In the similar way, we can find out the value of cos theta, then tan, and then cosecant. Here I just tell you one more thing. Sometimes the question like that, at what angle the sin theta that is equal to cos theta? So the answer is yes, the answer is 45 degree. As at 45 degree, the sine is 1 by root 2 and the cos theta is also 1 by root 2 and both of them having the same value. So it means is that both of them are equal at 45 degree. Now here there are some applications of trigonometry. The main use is in construction, or else this field of mathematics can be applied in so many ways. There are so many things, there are so many places where we can use it in electric engineering, in civil engineering, chemistry. There are so many things in where we can use the trigonometry. Here in this slide you can see that the real life application of trigonometry, the pyramid of Giza. If you will see that, we can find out the height, and in fact you don't know that by when they were constructed the pyramid, there is a use of trigonometry also. So the construction of pyramid that is based on the trigonometry, and this is the wonder of the world. Next is Jantar Mantar, that is also based on the trigonometry. How it is working, its basically major role is calculating distance between stellar object and their path. That is also based on the trigonometry. The next is Grand Canyon Skywalk, that is also based on the trigonometry. This is a day-to-day life major examples that is based on the trigonometry. Now here there are some trigonometric identities. These are very important identities. Let me discuss one by one. Basically, we have three identities. So let me start with the first identity. The first identity is sin square theta plus cos square theta equal to 1. This is the basic identity. We can make two more formula by using this identity. The first formula is sin square theta, that will be equal to 1 minus cos square theta. And the second is, if we have to find out the value of cos theta, so we can find out cos square theta, that will be equal to 1 minus sin square theta. Now the second identity, that is cosecant square theta minus cot square theta equal to 1. And we can make two more formula by using the same identity, that is cosecant square theta equal to 1 plus cot square theta. And the second is cot square theta, that will be equal to cosecant square theta minus 1. Here the third one identity, that is secant square theta minus tan square theta equal to 1. Again, we can create two more formula by using the same identity, that is secant square theta, that is equal to 1 plus tan square theta, and the tan square theta, that is equal to secant square theta minus 1. Here are three results that we are using in the trigonometry. As all of you know that the sine is a reciprocal of cosecant theta, so when we multiply both of them, we get the 1. Similarly, cos theta is a reciprocal of secant theta, so when we multiply both of them, we also get the 1. Tan theta is a reciprocal of cot theta, so tan theta into cot theta, that is also equal to 1. So now this all is the trigonometry chapter. In the conclusion, trigonometry is a branch of mathematics with several important and useful applications. Hence, it attracts more and more research with several theories published year after year. So student, thank you so much. Now, I hope that all of you get clear all the concepts. Thank you student and have a nice day.